Guys, welcome to Bearable. Guys, in this video we'll be talking about a very important concept in capital budgeting, and that is the concept of internal rate of return. So what is internal rate of return? It is the discount rate that equates the present value. Remember, whenever you see the term present value, it means that we will discount the cash flows. Okay, so it equates the present value of the future net cash flows from an investment project with the project initial's cash outflow. So initial cash outflow, let's suppose in our case, is 40,000. Okay, so what IRR is that when we discount our cash flows, future cash flows, at a certain percentage. Okay, like in this example we have written that IRR 1 plus IRR power 1. This means that at the end of the year 1 we'll be discounting it with, let's suppose our IRR was 10%. It means that the discount rate which equated the present value of our future cash flows with the initial cash investment was 10%. So how we'll do is that 1 plus 10% over 1 at the end of year 1, then at the end of year 2 1 plus 10% raised to power 2, then so on, and until the end of year number n we'll do it with the raised to power 1. So let's calculate it with the practical example and you will be in a very good position to understand it. Okay, so here it is, IRR solution. Remember, in our case the initial investment was 40,000 and the cash flows were in year 1 they were 10,000, in year 2 they were 12,000, in year 3 they were 15,000, and year 4 10,000, and year 5 7,000. So that's how we do it. In year 1 we take the power of 1, in year 2 we 2 and take the power 2, and so on. So find the interest rate that causes the discounted cash flows equal to 40,000. So what we have to do is that we have to find this IRR that equates, when we will discount these cash flows, which will equate to 40,000. Now how will we find it? Well, we will find it through trial and error method. Okay, so let's move forward here. This is the example of trial and error method. Remember that you have to use these present value interest factor tables. Okay, they are often given at the end of your book, and you will have to use those tables to calculate the present value. For example, in the first year our cash flow was 10,000. So in the table you will see that year number 1, you will select year number 1, and in the table different years are given, different percentages are also given, that is different interest rates, and you will take the interest rate of 10%. Okay, just to calculate that what 10% will give us IRR, what 10% will give us an IRR of what figure. So if we use these figures, like in year 2 we will take the value of present value interest factor from the table, then similarly year 3. So in the table if you look at it, then 10% rate for 1% for year 1 gives us this present value interest factor of 0.909. Second year 10% in year 2 gives us present value interest factor of 8.2. You see that this is decreasing because over the year the time value of money decreases. That's why we will have to multiply our cash flows like 10,000, 12,000, 15,000 with the lower amounts, because future cash flows are worth less than the cash flows in it today. Okay, so these percentages, these present value interest factors are decreasing day by day. So when we'll sum these discounted cash flows, our net cash flows will be, and we subtract these discounted cash flows from our initial investment, we will get this amount of 41,000. Okay, 444. This means that the rate we used for calculation of IRR purposes was too low. Okay, rate is too low. Why? Because had we used a higher rate, our cash flows, discounted cash flows, would have been less than 40,000. Since we use a lower rate, our cash flows, our discounted cash flows are still more than 40,000. So we know, okay, for one reason, that our IRR, that is the rate which will equate the present value of cash flows equal to 40,000, will be more than 10%. Okay, because if it will more than 10%, then this 41,000 might equate to 40,000. Now how much more? Well, that's where trick comes in. Okay, so this is the trial and error method. So we took another percentage, we took 15%. Okay, and we similarly use the same factor from table, we picked these values and when we increase the interest rate to 15%, our basically present value of discounted cash flows came to 36,000. Now this means that we have used a rate too high. Okay, if we reduce this rate, then this 36,000 will increase and it will come closer to 40,000. So we know now that our IRR is somewhere between 10 to 15%. Now how we will determine exact figure, that's, let's move to next slide. Okay, this is very important. Okay, just stay with me and you will understand it. Okay, remember at 10% when we calculated the discounted value of cash flows, they were 41,444. Okay, our basically initial investment was 40,000, and when we calculated the present value of our cash flows at 15%, they were 36,844. So first talk about the difference between 10%, okay, and the supposed, the initial investment, because when our what will be the discount rate, our IRR, supposedly IRR, which will equate the discounted cash flows to 40,000, because 40,000 is the initial investment. So the difference between the discounted cash flows at 10% and the IRR is 1,444. We simply subtracted 40,000 from this figure, 41,444. Now what's the difference between the IRR, difference between the present value which we calculated at 10% and we calculated at 15%. We will subtract 36,841 from 41,444, and it gives us the figure of 4603. Okay, so now what we will do is that, because we have to find this x, okay, and this x being IRR. Okay, so x, when we calculated the difference of this x, remember 10 minus IRR gives us this figure of what we have to add it to 10% to make it to IRR. So the difference of 10% equates to 1444, and the difference of 5%, 10% minus 15% gives us 4603 here. So now we will just solve this equation, and what we get here, and this is the same one, and when we solve this equation, this is the answer we get. Okay, we multiplied this, rearranged the equation, and we multiplied it, and the answer we got is 0.0157. okay, this means that when we travel from this 40,000 to 41,442, in between we had to add to 10% 0.0157, that is 1.57, so that our discounted cash flows equal to 40%, they equate to 40%. This means that our IRR is 11.57%. remember, we were already at 10%. At 10% we were already at this figure of 41,444. Now this means that we had to increase the interest rate so that our discounted cash flows decrease to 40%. okay, so from 10% we increased our rate by 1.57%, and we reached at the discounted cash flow figure of 40,000. So our IRR basically is 11.5%, because this equated our future cash flows to our initial investment. I hope this video clarified your concept. Now let's talk about the decision criteria. Remember that the management of the basket wonders, remember our company has determined that the hurdle rate is 13% for the projects of this type. Should the project be accepted? No, because the firm will receive 11.57% for each dollar invested in this project at a cost of 13%. Remember, the firm incurred the cost of 13%. okay, they got the funds from somewhere, from bank or anyone else, at 13%, but they are earning 11.57% from this project, because their cash flows, when discounted to make them equal to initial investment, they are 11.5%. so they are already incurring a cost of 13%, whereas their project is returning them 11.5%. so they will only accept the project if their IRR is greater than 13%. so in this case, of course, they will reject this. Now of course you can also find IRR, which is an easier way through this calculated taxes instrument calculator, but it's not allowed in some exams, so we will not go into detail. Okay.